Tired of the drudgery of turning that crank by hand all day long? Arms aching at the end of a long day in the shop? You need power feed. Hi, it's Frank Hoose from MiniLathe.com. Today's project is to install a power feed on this Little Machine Shop model 3990 mini mill. And the power feed that we're going to be looking at is a new product. It's manufactured by SIG, same company that makes the mills, and sold by LMS. But if you're interested in this at all, you should be aware right off the bat that there are actually 4 different models of this power feed. And the reason for that is that it can work not only on this model of the mini mill, but also on several other models, including the X2D, which is a similar mini mill sold by LMS. Now there's also similar mini mills that are sold by Micromark and Grizzly and Harbor Freight that will also use this same power feed. So if you have any one of those mills and you're interested in adding a power feed, there's a version of the power feed that will work. When you go to the LMS website, you'll actually see that there are 4 different models. There's 5111, 5112, 5113, and 5114. So be careful if you do decide to order these that you get the right one for the machine that you have. Here are the components that come with the kit. Over here we have the motor drive unit, has the speed control and the motor, and then there's a gear reduction built in here. And this is the clutch unit that engages between the motor and the table. And this knob lets you engage or disengage the power feed. When it's disengaged, you can use the hand wheel and have it turn freely, which is really nice. This here is the limit switch, which mounts to the front of the table. At least in some mills it does. I think it mounts to the rear on some of the others. But it has these 2 spring stops that mount to the front of the table, and when the table reaches the limits of its movement left and right, these contacts operate this limit switch to stop the power feed. Of course, you have some assorted screws here, and then back here is the power pack, which plugs into AC, and then the DC output plugs into the back of the motor drive unit. So the installation looks pretty straightforward. There is a manual, but it covers all the different variations, so it actually looks more complicated than it really is. And if you see this picture here, it shows the 4 different sizes of that transmission block for the different size mills. But if you strip this down to just the essentials for any one mill, it's really pretty streamlined, and it should be a fairly quick and easy job. So we'll go ahead and get started. Well, our first step is going to be to remove these 2 socket head cap screws, and they're 6 millimeters, but I use the 5 millimeter hex wrench. I'm going to use this T-handle wrench, which makes it relatively easy to just spin it off. Alright, and with those 2 loose, I'm going to pull out now on this end plate. May have to wiggle a little bit, and it should just slide right off of there. And as you can see, this has a brass bushing in here that acts sort of as a bearing for this end of the lead screw here. And the end of the lead screw has a slot in it. We'll zoom in on that and take a look. But I did want to mention this is the model 3990 mill. But with different types of mills, this end plate could be any of several different configurations depending on the model of your mill. So don't be surprised, but the manual covers those variations, or at least some of them. Well, next we'll mount the clutch mechanism onto the end of the table. But if you look down inside of this brass bushing here, you'll see that there's sort of a screwdriver-like projection that needs to engage with this slot in the end of the lead screw. Now that's the configuration on this mill. It might be a little bit different on others, but there's no way I've found to turn this internal one here, so you may need to turn the lead screw so that the slot engages with the projection. So once that's done, you can slide the two together here. You may have to finagle it back and forth a little bit until they engage, but when it's engaged, the clutch mechanism should come up flush with the end of the table. Now we'll go ahead and get our screws in place. Okay, and with those, you want to snug those down and then check to make sure that there's no binding on the lead screw. So I've got those tightened down a little bit here, and now I'll go down and turn the X-axis hand wheel and make sure that it's moving freely without any apparent binding. So before I mount the motor drive unit to the clutch, I want to go ahead and just run a test on this and make sure it works properly while it's here on the bench. That way, if there's any problem, it's easier to check it out before I mount it. So I'm going to go ahead and plug in the power. There's a power socket here on the back. You just take the DC end of this and plug it right in there. And it doesn't actually seat in there all the way to the bottom. It's about a 1/4 inch still sticking out, but that's how it is. Anyway, and with that now in place, the green pilot light is illuminated. And I'll tell you later about this fault light, but it should not be illuminated right now. And now we can select the direction switch. The direction switch has 3 positions, 0, left, and right, which indicates the direction of table movement. And then the speed control is turned to 0, and it has a click stop at the 0 position, as you can hear. So we'll go ahead and turn it to move the table to the left. Then we'll advance the speed control. And as you can probably see, the shaft is now turning. We'll go ahead and advance the speed control. And that's the maximum speed. And we can go ahead and flip it to the 0 position and reverse the direction with the toggle switch. Or you can reduce the speed and bring it back to 0 and click it off that way. So you can turn it off either way, and I'll maybe talk about that a little bit later. But now we know it's working, we go ahead and get it mounted onto the clutch mechanism. Well, the next operation is to mount the motor drive unit to the clutch housing, and they're just 2 small 4mm M4 by 0.7 metric screws here that join the two. But you have to line up the key on the shaft with the corresponding keyway down here, and once again you can't turn either of them very easily, so you may have to sort of flip this upside down temporarily and then bring it around after you get the key engaged so that the key and the keyway are lined up. At least that's the way I did it. And now here's a case where a ball end hex wrench really comes into handy. If you aren't familiar with these, they have sort of a little ball on the end here that allows you to rotate the wrench in a small arc, so that in a tight space like this you can get the tool right down there where otherwise it would be very difficult to reach in here with a conventional hex wrench. You could use a conventional wrench, but it would take a lot of turns. You know, you'd have to go like a half turn at a time, which would be a very slow and cumbersome way to go about it. So get yourself a set of these ball end hex wrenches and the job will be much easier, and you'll find many other uses for them around the shop. After trying to mount the motor unit to the clutch, I determined after a while that the 2 holes in the motor mechanism are slightly too close together. I suspect that's a side effect of the injection molding process that just left them a little bit off of register. But in any case, the easiest way to fix that seemed to be to drill them out to a slightly larger size. So I went in with a number 50 drill, just enlarged those holes slightly, and that was all it needed to solve that problem. So we'll go ahead now and remount that with the slightly larger holes. With the drive unit now mounted, let's go ahead and do a test and see how it works. So I'm going to shift it to move to the right, and then we'll advance the speed control knob just a little bit until it starts to go. And turn it up a little bit more, and the table's moving. Okay, then we'll stop it by moving to the 0 position, and go move to the left. Increase the speed. Alright, so everything looks good there. The next thing we need to do is connect the limit switch. We're ready now to install the limit switch on this particular mini mill. It mounts right here to the front of the table assembly. But on some of the other mini mills, particularly the tilting head type, it mounts on the back side of the table, which is more complicated, but I'm not going to go into that here, but I did want you to be aware of that. Now this is a little tricky because we have 2 socket head cap screws, but they have to go down underneath here, so we're kind of working in the blind. You can't really see the screws while you're trying to put them in, so it takes a little bit of feel to do that, but it's easier if you move the table back closer to the column, so you have some clearance here between that and the hand wheel. Alright, so I'll take my first screw and just get it started in the hole, then take my little ball end hex wrench here and get that started in the hole, give it a few turns. And then before I tighten that one up, I'm going to go ahead and take the second screw and drop it on the floor. And then after retrieving it, I'll lift this up while I still can here and see if I can get it started in the hole, and then bring it down. That hopefully will make it a little bit easier to line it up with where it's got to go. The plug end here connects with this socket on the motor unit, and there is a notch here that has to line up with a corresponding key, and the notch goes to the 6 o'clock position, so you may have to turn that back and forth a little bit, but once it lines up, it'll push right in place, and you can just tighten this locking ring on here, keep it in place. Now that we have the limit switch mounted, one thing that becomes evident is we have this long cord sticking out here. So I decided to go ahead and mount a strain relief down here on the base, and that takes up the extra slack in that cable and hopefully will prevent it from getting tangled up in something. But this base is just 2 pieces of laminated shelving of the type that you can get at the big box hardware stores, and it's 1.5 inches thickness with the 2 of them together, and that gives adequate clearance to be able to turn the hand wheel easily without your hand getting caught underneath the roller here. Another advantage of this base is that it provides a broad enough platform so that the mill will not tip side to side. It's a lot more stable with this base in place than without it, and in fact I wouldn't be comfortable using the mill without this wider base unless it was bolted down to a bench top or something. But this is one of the fixed column mills, so the column does not lean left and right as it does on the so-called tilting column models, and therefore this space is actually wide enough. So it works out real well, and it also slides easily if I need to move it. Not so easily that it's going to move around, but easily enough that if I apply some force I can move the mill a few inches one way or the other on the bench top if I need to. Now we'll install the limiting plungers on either end of the table. And these are little spring-loaded plungers, but they mount in the slot here on the front of the table. And if you look at them, you'll see that they could be oriented this way or that way, but you want them oriented so that the plunger is in the lower position. So this one's going to go on the left end, and then you just tighten down this nut here, and it clamps like a miniature version of the clamps on the table. And for as a starting point, we'll just mount it here near the end of the table. And I want to tighten up these little screws. They just hold the screw in place, but they shouldn't be loose enough that they might fall off. All right, so that's good. Now we'll do the same thing with the one on the other end. This is an 8mm wrench that I'm using. Make sure that'll work. Okay, and that should do it. All right, with the limit stops now set, let's go ahead and run it end to end and see if they work properly. So I've got it on the highest speed here. It's cruising right along. When you first test this, keep a careful eye. You don't want if something doesn't go right, you don't want it to jam up against the end of the table. Well, I don't know if you saw that, but as it approaches the switch, the spring here pushes in and it comes to a stop kind of gradually. Here we go. Let me zoom in on that and give you a closer look at what's happening. On this switch housing, there are actually two buttons, one on either side, and they are engaged by these spring-loaded plungers here. And the purpose of the spring is that the table, when it's moving, especially if it has a heavy workpiece on it, has a certain amount of inertia. And even if you cut off the power to the motor, the table's going to glide for a little bit of distance. If you had a solid stop, it might keep going and just crush the switch. So this spring plunger arrangement here prevents that or helps it come to a gradual stop. So let's try that again. So you can see it went in about maybe half a centimeter, quarter of an inch or so before it finally stopped. All right, so that's how that works, and I like to keep these pretty close to the ends of the table so I have as much use of the full range of the table as possible. But the idea here is you don't want the power feed to drive the table past its end point, obviously, so you want a little bit of clearance there, and these are set up so that you naturally get that even if you set them all the way to the end. The clutch mechanism can be used to engage and disengage the power feed, and I believe its main purpose is that there are a lot of times when you want to manually adjust the table, particularly if you're trying to line the table up using an indicator or a DRO or something, and you need to make very small incremental movements. It's hard to do that with the power feed engaged because when you turn the lead screw, you're actually trying to turn the motor of the power feed through the gear train that's in here. So it's much easier if you can disengage the power feed when you need to make those fine manual adjustments. And that's what this clutch here allows you to do. That's actually a great feature because the power feed I have on my larger mill does not have that feature. And I have a lot of trouble sometimes when I'm trying to line up to the 0 mark on the digital readout. The detense feel of the motor actually makes that hard to do. So this is a great feature, and I wish I had it on my other one. But we'll see how it goes. Okay, so when it's moving, I can disengage the clutch or re-engage the clutch. So this is another way to start and stop the power feed. The other way, of course, is you can just move the switch to the middle position. And a third way is you can turn the speed control to 0. But the difference is when you turn the speed control to 0, there's a little bit of a coasting effect, whereas if you use the clutch, it stops right away. So that can be beneficial in certain situations. If you're cutting up to an edge or something like that and you need it to stop quickly, that's the way to go. On the control panel here, you can see that we have the power light and the fault light. The fault light normally will stay off all the time, and the exception is if you generate an overload condition by running the table under power feed into some immovable obstruction. For example, if you were to run the tool into the side of the vise or something disastrous like that. But anytime, if you were taking a very deep cut and the amount of force required to move the table was excessive, it could cause overload to the motor, and that would cause the fault light to come on. The motor would stop, And then to reset that condition, you have to turn the speed control to 0 and then clear the condition and then start again. So hopefully if you're watching what you're doing and being careful, you should rarely, if ever, encounter that, but that's what it's for. And it does protect the motor from overload. I also wanted to mention that the power light stays on all the time, and the little power pack that provides power to the unit, well, you can't see it because it's back behind here, but it's plugged in and it doesn't have an on-off switch. So when this thing's not running, I don't think it uses very much power at all. But if you're for safety reasons, or just if you want to conserve power as much as possible, you may want to get a power strip and plug both the power feed, power supply, as well as the mill itself into the power strip. And then when you're done with your work for the day, you can just flip off the switch on the power strip, and that will turn the power off on the power feed as well as to the mill. Now, naturally, you want to turn the mill off using its own power switch, but that would give you an extra margin of safety if some person were to come in and punch the start button on your mill. If you've watched some of my other videos, you may have noticed that I'm particular about sharp corners on machine tools. And this is a good example where you have a real sharp corner here. And I will take a file and file that down. Anytime you're working around machine tools, you get preoccupied with what you're doing. And it's very easy to jam your elbow or wrist or finger or some other part of your body into a corner like that. So in any case, I don't like these sharp corners. The rest of them are all nicely rounded, but these 4 corners, 2 here and 2 here, I'm going to take a file to those, probably these ones underneath as well, just to make it a little bit safer. Now, naturally, that's going to remove a little paint, but I'm willing to, I'd rather remove the paint than remove some flesh from my hand. So solving that problem, really not much to it. Just get yourself a little file and take some strokes over there. And it's already a lot safer than it was. I got my first mini lathe from Harbor Freight in 1999, and it wasn't long before I decided I really had to have a mill. And that was just about when the mini mill first came to market in the US. And I got it, and I was really excited about it. But before long, I got tired of turning the hand wheel on the X-axis and started thinking about it would be nice to have a power feed. And there was none commercially available, at least none that I was aware of back in those days. So I set out to make one, and I scavenged some parts, some motors and gears from an old dot matrix printer, and set out to build one. And it's a kind of a quaint story, I guess we'll say. I didn't have much experience with the mill back then, or modifying machine tools in general, but I did get the job done, and it actually worked quite well. It looked kind of scary, but it actually worked well, and it worked for years until I sold that mill to a buddy of mine, and he was still using it up until the last time I contacted him. So there are ways to go about building your own if you'd like to do that, but if you just want to get the job done, this is the way to go.